Right, Nana. Good morning, good evening, good afternoon, good night. So, whatever it may be. Okay, right? Nana. Previous class, we completed the ray diagrams on concave mirror. Am I right? Now, today, let us discuss about that ray diagrams on convex mirror. Ray diagrams on convex mirror. Okay? Ray diagrams on convex mirror. So before going to discuss that, in case of concave mirror, no, concave mirror forms. Once again, we have to recall concave mirror forms. Which type of mirror? Which type of images? So one thing is real images. Concave mirror forms real images as well as virtual image also. Virtual image also, and it forms inverted as well as erected also. Invert images and as well as erected images also found, and diminished and also enlarged and highly enlarged also formed in this case. So in case of concave mirror, real and virtual images are formed depending upon the position of the object. Inverted erected images are formed depending on the position of the object, and it forms diminished image and as well as enlarged images depends on the position of the object. That means when object is placed at different positions, we get that the real images or virtual image are inverted, erected, diminished, enlarged and different positions of the image distance. Clear? So in previous class we discussed about this one. Clear? Now let us discuss what are the characteristics formed in case of the convex mirror. Okay, how like the image is formed, that means ray diagram. So let us let us go to draw the ray diagram and as well as discuss the characteristics of the image which are formed by the convex mirror. Then before going to that, so what is the picture of that, means what is the diagram of convex mirror? So convex mirror, okay, this is the curvature. So if the reflecting surface is inward, if the reflecting surface is outward, that means silvering surface is inward. So this is the silvered surface, and this is the reflecting surface. This is the reflecting surface. That means if the reflecting surface is outward, such type of mirrors are called as the convex mirrors. So for example, if we can draw like this, so inward silvering and outside it is the reflecting surface. So reflecting surface means light rays are incident on the outer surface. Such type of mirrors are called convex mirrors. Convex mirrors. For example, if the mirror is like this, okay, so inward silvering and outside is the reflecting surface. Outside is the reflecting surface means light is incident on the outer surface. If it can be reflected back, then such type of mirrors are called as the convex mirrors. Clear? Convex mirrors. So simply convex mirrors means reflecting surface is outer. So outer surface is nothing but reflecting surface. Then such type of mirrors are called as the convex mirrors. Okay, right? Understood? No. So you have to draw like this or like this, whatever it may be. So you have to remember one thing. If the silvering is inward and reflecting surface is outward, such type of mirrors are convex mirrors. Okay, that's it. Right. Now let us draw the ray diagrams on convex mirrors. Then in case of concave mirror, we discussed already. In case of concave mirror, there are 6 cases. But here there are only 2 cases. Those 2 cases are first one when object is placed at infinity. When object is placed at infinity. When object is placed at infinity, So where we get the image? On the convex mirror. So this is the case one. When object is placed at infinity. Let us draw the diagram. Okay, clear? Right. So let us draw the convex mirror. Okay. So convex mirror, I can draw convex mirror, and this is the pole, and this is the principal axis, that line, and the center of the mirror is nothing but pole. Okay, done. No. So here there is a center of curvature C, and there is a midpoint focus point. In case of convex mirror, the center of curvature and focus point are the behind the mirror. Actually, this is the reflecting surface. That's why it is acting as the mirror. And behind the mirror, there is center of curvature and focus point. Clear? Right. When object is placed at infinity, we know that when object is placed at infinity means the rays coming from the infinity are sorry. The rays coming from the infinity object are parallel rays always. If the object is placed at infinity means we have to take the parallel rays. So that means when object is placed at infinity, we have to take the parallel rays. So let us take first ray. Let us take one incident ray coming from the object which is placed at infinity. Okay, this is the first incident ray which is parallel to the principal axis and incident on the mirror. So obviously we know that when it is incident on the mirror, what happened? It can be reflected back. How like it can be reflected back is must. So when light is incident the mirror and which is the parallel to the principal axis, if the ray is parallel to principal axis and is incident on the mirror, then obviously it will be reflected. How like it will be reflected? Let us see. So we know that the rules to draw the ray diagrams. So according to that rules, if any incident ray which is parallel to the principal axis, incident on the mirror, okay, if it is concave mirror, it can passes through the principal focus. But it is in case of convex mirror, it is incident on the convex mirror, that parallel ray incident on the convex mirror, after reflection, it appears to diverge from the focus point. Means this is the focus point. Actually it reflected back like this, but from where it appear diverge from the focus point. So let us draw like this first of all, then we can be reflected back. Understand? It appear diverge from the focus point. Clear? So it is one parallel. So let us take, we need at least two rays to draw the ray diagram. So to get the image. So let us take second incident ray which is parallel to the principal axis here also. Second light ray coming from the object placed at infinity, and it is also incident on the mirror, means convex mirror. We know that same rule. It also appear to diverging from the focus point. Means we have to draw like this dotted lines, and from here reflected back like that. One second. You have to use the scale. When you are drawing the ray diagrams, don't draw it like this, but you have to use the scale. Okay, you have to use the scale. So if you can observe that these two reflected rays meet at one point, that is the focus point. That means image is formed here. So when object is placed at infinity, image is formed at F. So now let us draw the characters. So let us write the characteristics of image. So characteristics of image. Characteristics of image when object is placed at infinity in front of the convex mirror. Now which type of image is formed? First, where it is image is formed. That means the position of the image is what? The position of the image is F. That means image is formed. Image is formed at F. Image is formed at F, and behind the mirror. Where is the F here? Behind the mirror. This is the position of the image. Next, what about the size? Diminished image. Size is diminished or point sized image. Diminished or point sized image we get. Next, third one, third one, it is formed with the dotted lines and which can't catch on the screen this image. That's why it is the virtual image only, virtual image only, and all virtual images are mostly erect images, erected image. Virtual and simply we can write virtual and erect image. Then like this, when object is placed at infinity on the convex mirror, so we get the image at formed at f and it is behind the mirror and diminished or point size and virtual image and erect image. Okay, right? So convex mirror, when object is placed at infinity, it forms the diminished and point sized image and virtual and erect image. So this is the first case. Now let us the second case. Let us go to second case. Okay, right? So pause the screen. That means just you have to pause it and you have to note down. Okay, right? Okay, right? Note down. Right, Nana. Let us go to next one. Okay. Case 2. Case 2. Case 2 is when object when object is when object is placed at a finite distance, placed at a finite distance in front of the convex mirror, in front of the convex mirror, in front of the convex mirror. That means what? It is placed at a finite distance in front of the convex mirror. Means what? In front of the convex mirror, whatever it may be the position of the object, let us take. Okay, or simply it can be written as or also. That means when object is placed between infinity and pole, infinity and so object is placed at infinity, we completed. But now let us discuss object is placed infinity and pole, between infinity and pole. That means what? Whatever it may be the position of the object in front of the convex mirror. Simple. So let us draw the convex mirror. This one. So let us draw the convex mirror. This is the convex mirror. So let us take pole, and we know that center of curvature and focus point. In case of convex mirror, center of curvature and focus point behind the mirror only, because of it is the mirror, it is the reflecting surface. So outer surface of the reflecting surface is the mirror. That's why it is called as convex mirror. Clear? So now an object is placed between infinity and the pole. Now infinity means somewhere distance and pole. So let us take finite distance in front of the mirror, finite distance, otherwise between infinity and the pole, whatever it may be. That means object is placed at here, whatever. For example, object is placed. Otherwise object is placed at. Otherwise object is placed at. Whatever it may be the position of the object, irrespective of the position of the object, we get the same characteristics. That's why with this one. But in case of concave mirror, object is placed between F and P, object is placed at C, object is placed beyond C, like that. But here there is one thing only, between pole and something distance, something finite distance. Clear? That one only clear. So let us draw the object. For example, so let us take object. Otherwise, let us take one object. Okay, Otherwise you have to take like this also object arrow mark also object. Let us take for our convenient, so object, for example this is the object. Okay, extended object. No, first ray, in every case first ray we have to take the parallel ray which is parallel to principal axis. That means incident ray which is parallel to the principal axis. The incident ray which is parallel to the principal axis, first ray. We know that the ray which is parallel to the principal axis incident on the mirror, after reflection, after reflection from the convex mirror, after reflection it is appear to diverge from the focus point. Appear to diverge from the focus point. So appear to diverge from the focus point like this. Okay, appear to diverge from the focus point like that. So let us take the second ray. Okay, let us take second ray. There are four cases are there. For example, if second ray it is passing through the focus point in case of convex mirror, but it appear passing through the focus point, or it is directed towards the center of curvature, or it is directed towards the focus point. So let us take it is directed towards the focus point. Okay, it is parallel to the principal axis, after reflection diverge from the focus point. Let us draw second ray. It is directed towards the focus point. That means like this. Okay, it is directed towards the focus point. Directed towards the focus point. That means principal focus. Then what happened after reflection? After reflection, it is parallel to the principal axis. Okay? If it is parallel to the principal axis after reflection, diverge from the focus point. If it is directed towards the focus point after reflection, parallel to the principal axis. Okay, according to the rules to draw the ray diagrams. Okay, right now. Now it is one ray reflected ray, it is another reflected ray. So already this reflected ray extended back. So we can extended this reflected ray back like this, like that. Then if you can observe that clearly, here we get the image like this. Understand? Here we get the image like this. So now it is the object, it is the image. Okay, right? Right, man. Now characteristics. Characteristics of image. Characteristics of image. No, first, what is the position of the image? We can discuss. No, position of the image. It is formed behind the mirror between P and F. Am I right? No, when object is placed at infinity, image is formed exactly at F. But when object is placed between infinity and the pole, otherwise, irrespective of the object position, whatever it may be the object position in front of the mirror, whatever it may be the object position in front of the mirror, other than infinity, that means from here, whatever it may be the position of the object, we get the image between P and F. So image is formed between pole and focus point. Image is formed between pole and focus point, behind the mirror. Where is the pole? Where is the focus point? Means behind the mirror. Behind the mirror. Clear? Right. Next. Position over size. If you can observe the size of the object and size of the image, size of the image is less than the size of the object. That means size of the image is smaller than that of the object. That's why we can call it as a diminished image. Diminished image means smaller than the object size. Diminished image. Right. Third one. It can't be catch on the screen. That's why it is formed with extended lines. Definitely it will the virtual image. It is virtual image, and it is erect image also. It is formed above the principal axis. That's why it is erected image. Okay, right? No. So finally we conclude that one thing, irrespective of the position of the object in case of convex mirror. So finally, in case of convex mirror, if you can observe that, in case of convex mirror, always forms see virtual images. It forms always virtual images, and it forms always erect images, and it forms always diminished images, if you can observe that clearly. So understand what I say. Then convex mirror always forms virtual, always forms erect, always forms diminished, always.